So the next point in our transformation geometry studies is going to be enlargements. So we've done translations, we've done rotations, reflections, and now we still have to do enlargements, stretches, and some other transformations like inverse, combinations of transformations and such. So enlargements, basically we have a shape and we're either going to make it smaller or larger. Usually we're going to have what we call a center point and a scale factor. So let's take a look at one example. So if you look at the screen here, let me show you a few things. All right. So first of all, we have our center point here, C. Okay. So this is where we're going to measure our distances from. This is our original triangle, PRQ, and basically we want to make this triangle 3 times larger. Okay, so this is our original triangle, and we're going to get our P prime, R prime, Q prime. But how do we do that? Well, first, notice we can measure any of the distances by using Pythagoras. So if we take a look, there's a triangle here, CR, and there would be like a right triangle up here. So if we wanted to measure this distance, we could, right? This distance. Now, if I'm telling you that I want something with a scale factor of 3, that means that all my new lengths will be 3 times larger than the previous ones. So how would you do that? Let's assume that you were given that K was equal to 3, and you were given this triangle and the center points. So what you can do here, for point R compared to point C is going 4 to the right and 1 down, right? So if it's going 4 to the right and 1 down, my new point, which would be 3 times that, instead of going 4 to the right and 1 down, it's going to go 4 times 3 to the right and 1 times 3 down. So what I mean is, this length was 4, and this height was 1. If I'm looking for R prime, this new distance, since my scale factor is 3, this new distance will be 4 times 3, which is 12. And this new distance will be 3 times 1, which is 3. So I can find my point R prime, right, just by going 3 times. So this is actually the original coordinates 4 compared to C times K. In this case, K is 3. I'm enlarging my picture by 3, making it larger. And here it's the same thing, but it's K is, this is 1 times K, so that's 1K. 1K. Right? We can do the same thing, exactly the same thing for the other points. So let's observe now. Let's see for point P. So now we're looking at this point and we want to find P prime. How much have I gone down? 4. So this length was 4. So we can already calculate that this point P prime is going to be a 12. So this whole length should be 12. Right? If you didn't know, then you would be able to calculate. If you didn't have all this image. Same thing here, forward, it's 3 forward. So since it was 3 units forward, now it's going to be 3 times K. So now it should be 9. And if we count, we can clearly see that this is 1, 2, 3, 4, 5, 6, 7, 8, 9. We could do the same thing for Q. So point Q, we had our point Q here, which was 1, 2, 3, 4, 5, 6, 7 to the front. Right? 7 ahead of C and 3 down. So this is 3 and oops, and this is 7. Well, k equals 3, so we know that our new point Q prime, this distance, should be 7 times k, which is 21. Case 3. For the height, our point Q was at 3, so now it should be at 3 times, so 3k, which is 9. And we can count 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. So for enlargement, that's usually what we're going to do. But what about for making things smaller? What about reductions? So let's see this different example now, right? And well, it's basically the same thing, but now our scale factor is going to be a number which is less than 1. So in this example, let's say the k is a half. So I want to make my triangle. In this case, my triangle is KLM. Okay, and I want to make it twice, half the size. So each length should be half now. So again, what's my original length here? So CQ, let's write some things down. My length CQ was 2, 4, 6, 8, 16. If you count all the squares, x was 16, and our height, CK, sorry, our point K. So our height, 1, 2, 3, 4, 5, 6, 7, 8. So if I want to make it half the size, CK prime, well, since our scale factor is a half, that's half of that, and half of that. So if we do 8 and 4, 1, 2, 3, 4, 5, 6, 7, 8, and 4 up, 1, 2, 3, 4. So we find our k and k prime. And we can do the same thing for L and for M. If we look for L, what is the distance, what is the coordinate of L according to C? So if we start at C, how do we get at L? We have to go 18 forward and 2 up. So our new CL prime would then be, now it's half, so it's 18 times k, right? This is 18k and 2k. And k here is our scalar factor. It's nothing to do with those point k's there. So CL prime, it's 9 and 1. And we can see the height here is 1 now, and if we measure here, 3, 6, 9. Now, what about M? You can always pause and try it yourself. If we compare M to the position of C, M is 4, 8, 12 to the right of C, and it's 2 down. So what would be Cm prime? So it would be 12k. We've done the same thing here, right? It's just k is a half. But this applies to any case, and negative 2k. So since k is a half, that's going to be 6 and take away 1. So if we look at our drawing here, 6 and negative 1. So there we go. So a good thing about IGCSE is that the questions will only ask you about enlargements and reductions with the center in the origin. So your center will always be 0, 0. So when you're measuring those distances that I was talking about before, CM, the distance from the center to the point, that's going to be just the coordinates of the point. So you don't have to write those lines. It's going to be simpler. So let's take a look at an example here. So we have this triangle, which is ABC. So you have the coordinates there. So let's first try and solve it without drawing. So find the position of the image of triangle ABC under A, an enlargement with center 0, 0 and scale factor 2. So that's fairly simple. So let's see, our A was 1, 1. Wow. So it's undergoing a change, isn't it? It's undergoing an enlargement. So what would be the new value? Well, since k equals 2, A prime would be 1 times 2 and 1 times 2. What about B? B was 4 and 1, and our B prime, just multiply everything by 2, so 8 and 2. What about C? 1 and 4, everything is gonna multiply, so 2 and 8. What about letter B? We can draw, I'll show you the drawings later. What about reduction with center 0, 0, scale factor 1/2? Well, the working out is the same. The only thing that will change are the values. But it's, again, just multiply everything by your scale factor. So that's going to be 1/2 and 1/2. What about B prime? So B was 4 and 1. And now B prime would be 2 and 1/2. What about C prime? C was 1 and 4. So your C prime is now going to be 1/2 and 2. And you can see here how would the graphs look like. So in our first case, ABC, if we plot our triangle, that would be our triangle ABC. This is x coordinates, y coordinates. So A was 1 and 1, right? 1 and 1 here. B was here, 4 and 1, and C was here, 1 and 4. So our new triangle, which was enlarged, you can notice that this is 8, so all the coordinates, they check. So C prime here, this is 8, this down here is 2, our B prime, this is 8, this height is 2, and A prime is 2, 2, so everything matches. Now reductions, you can see there will be some halves here, right? So this is our original triangle, the same one. You can see that it's same scale. And now the smaller one, you can see it was 4, now it's 2, C prime's height's 2, x here is 1/2, height of B prime is 1/2, and this length here is 2, and A 1/2 and 1/2. There you go.